Inverse matrices and solving systems. So one of the methods for solving systems is to use an inverse, all right? And it's the same thought process as any multiplicative inverse. The multiplicative inverse matrix, and it's denoted like this, a to the negative 1 here, is some square matrix such that when you multiply them, you get the identity matrix. It's just like multiplying inverses in general. If you were to multiply any number and its reciprocal, you get 1, which is the identity. And so it's the same that's true of matrices. If you multiply a matrix and its inverse, you are going to get the identity matrix. So they've given us these two here, A and B. They want us to decide if they're inverses, and I'm just going to show you this. We're not going to do it out. But if you multiply them, you use your matrix multiplication where you multiply row by column and add row by column, so on and so forth. You'll see that you get this 1, 0, 0, 1. This is the identity matrix. If you multiply a 2 by 2 by this matrix, you get what you started with. That is the identity. You'll notice even if they multiplied it in a different order, because remember with matrix multiplication, order matters. But with inverses, it doesn't. If you multiply two inverses in any order, then you are going to get the identity matrix, all right? It doesn't matter what order you put them in. So that is what inverses look like. This is what happens when you multiply them. So we are going to talk about how do we find an inverse then? Because it's clearly not just switching numbers around, right? It's completely different numbers. And so there is a process, and it is at the top of page 169, finding the inverse, all right? So the first process is to find the determinant. So your first step in finding an inverse is to find the determinant. All right. And so if you have some matrix A, you want to find the determinant. Remember, it looks almost like absolute value. Find the determinant. And then to find the inverse, so let's say it looks like this. A, B, C, and D. These are your four elements inside of your matrix. You are going to take the inverse and you are going to put it over 1. All right, so that just represents the inverse. It doesn't represent absolute value. It just represents the determinant. So 1 over the determinant, and then you are going to multiply this guy, but not in the same order. All right, we are actually reversing some things. What happens is the first diagonal switches places. All right. So the first diagonal switches places. We flip the A and the D. We switch those places. All right. The second diagonal, they stay there, but we negate them. So this second diagonal, we leave where it is, but we negate those. All right. So this is my second step. I am going to take 1 over my determinant and multiply it by that switched around matrix. And then my last step is actually to multiply it through. So we're going to multiply that 1 over my determinant to each one of these. And you will then have your inverse. And so we're going to do a couple of these so that you can see it. Now there's one stipulation here. If my determinant is 0, I will not have an inverse, because I am multiplying by 1 over my determinant. So all of this stipulates on the fact that your determinant does not equal 0. All right, your determinant cannot equal 0. If it does, you cannot find an inverse. So let's first do this one right here. We are going to do the inverse of A. So my first step is to find the determinant. All right, so I'm going to do it just like I would. I'm going to say 1 times -4 minus -2 times 5. Remember, first diagonal, subtract the second diagonal. So I have -4, and this is minus a -10, so this is plus 10. So my determinant here is 6. All right, my determinant is 6. So my first step is find the determinant. My second step is to put 1 over that determinant, so 1 over 6. And I am going to multiply it through. I am going to switch these two. My 1 and my -4, I'm going to flip. So -4 goes up here, 1 goes down here. All right. My second diagonal, I am going to do the opposite. That +5 is now going to be a -5. That -2 is now going to be a +2. All right. And then my last step is just multiply it through. And you do want to simplify. All right. So I'm going to multiply it through. 1/6 times -4 is -4 over 6. 1/6 times -5, -5 over 6. 1/6 times 2, and 1/6 times 1. And then I want to take these and see if I can reduce them, which you can for a couple of them, right? -4 over 6 reduces to what?
-2/3.
Yeah. -5 over 6. -5 over 6 cannot reduce, so we're going to leave him alone. 2 over 6 can reduce, and 1 over 6 cannot. This is my inverse. This is my inverse, okay? So it's a little bit of a process, but it's not difficult. Just find your determinant, multiply it through to your switched around matrix, all right? Let's look at the second one, B. So my first step is to find my determinant. So I'm going to say -3 times -4 minus 6 times 2. 12 minus 12 is 0. If you get this for a determinant, you are just going to say that this is going to be an undefined, or I cannot find an inverse. You could say undefined. You could say no inverse. You cannot do this when you are done. All right, so if I wanted to then use the inverse, I would need to find it and then multiply by it. So for example, if I had something like 3x equals 4, something like that, I would say, well, I have to divide by 3, clearly, right? But technically what you're doing is you are multiplying by the reciprocal of that, the multiplicative inverse, all right? Because you're technically saying, okay, well, this reverse is 1/3 times 1/3. My x is going to equal 4/3. All right? So we actually have been using multiplicative inverses for a while. But now we're going to do it with matrices. So if I were to multiply this side by the inverse, I would get the identity matrix times another matrix. So if I multiply this side by the inverse, I will get x all by itself. And then what I need to do is I need to multiply the other side by the inverse, okay? Now I will say, when you multiply the right side, order does matter. So you do need to put the inverse times the answer. All right, so you do want to multiply it that way. If you look at it, that's going to be a 2 by, if you flip it the other way, it wouldn't multiply, right? 2 by 1 and 2 by 2 wouldn't multiply. So you do want to list the inverse first because order does matter on that side. It doesn't matter on the left because inverse times inverse is going to be the same. So my first step for these is to find the inverse of the matrix that is with my x, all right, or with my variable. Find the inverse and then multiply the other side by it. All right, so our first step here is to find the inverse of this. So I am going to find the inverse. So my inverse, I need to do 6 times 3 minus 2 times 8. So 6 times 3 gives me what? 18 minus 16. My determinant here is 2. All right, then I am going to say 1/2. And I'm going to reverse these, right? 6 and 3 change places. 8 and 2 just negate. And then I'm going to multiply that through. So my inverse will look like this. 3/2. Negative 8 over 2 is just negative 4. 1/2 times negative 2 is just negative 1. And then 1/2 times 6 is just 3. So this is my inverse, all right? So I have found my inverse. This first step here was just finding my inverse. All right, now I am going to take this inverse and I'm going to multiply this with matrix multiplication. So I'm going to say 3/2, negative 4, negative 1, 3. And I am going to multiply it by negative 2, 0. All right, so we're going to do row by column multiplication here. Row by column multiplication. All right, so this row by this column, we have 3/2 times negative 2 plus negative 4 times 0. That's an easy one, right? I'm done because I've already done that row and that there's only one column, so I'm going on to the next row. All right, my next row is going to be this one. Negative 1 times negative 2 plus 3 times 0. All right, that will be my matrix. 3/2 times negative 2, the 2's cancel. I just get negative 3. Negative 1 times negative 2 is 2 plus 0 is 2. So my matrix that I was looking for is going to be the matrix negative 3, 2. All right, negative 3, 2. All right, so you find your inverse and then just multiply it by the other side. Find the inverse, multiply it by the other